Hi there, everyone. I know this is a little later than I wanted it to be, but we've had some technical problems trying to get this done, and I've just now been able to get everything put back together again. So I hope we can get this all taken care of. A short video today. I just want to do a little review with you before we get into probability that we're going to be starting in class tomorrow. One other thing to note: I'm going to also give the sixes and the sevens some questions that relate to last year's EQAO. I want to get you ready for the tests. The EQAO tests rather, go the 28th, 29th, and 30th. So I want to make sure that you have a chance to practice some of them, both in terms of what we're doing mathematically and also what we're doing in language. Okay, I'm not going to be concentrating a lot on it. I just want to put your I want to put your minds to rest, thinking that you at least will have an idea of what to expect. Okay. Before we get into probability, I do want to mention a couple of things. The two most important things that we could look at to start this off, the two most important things that you need to know are how to turn percentages and decimals into fractions, and how to change fractions into decimals, and working with all three of those ways to report numbers. Okay, so today all I want to do is remind you of how to do this, give you a chance to practice some before you come into class. Okay, so let me give you a couple of ideas. Let me show you the following. Okay, it says express each one of these as both a decimal and then as a percent. Well, you know what? I know some of you are looking at these and saying, "Oh, come on! Some of these things are really easy, like this 9/50ths. I could figure that out with one hand tied behind my back. I can be blindfolded and figure out what 1/4 means. 5/8, 7/16. That's a little harder." But all of them are not as hard as you might think. Let's take a look at the ways to answer these questions. First of all, if you're going to turn a fraction into a decimal, one of the best ways to do it is to try to write an equivalent fraction using a denominator of 100. Now, for some numbers, it's really easy. I mean, 9/50ths, could you think of something easier? Take 50, multiply it by 2, and you get 100. Well, if you're going to multiply that number by 2, you have to multiply this number by 2, and you get 18 over 100. 18 over 100 is what decimal? Yeah, I can hear you right from here. It's 0.18. And if 0.18 is the decimal, what is the percentage? Yeah, okay. It's 18%. Now, if you're looking at this and you're saying, I don't understand how that works, look at this for a second, okay? 18 over 100 is 18/100ths. That's where we get this, okay? You with me so far? And this is 18% per cent, and cent meaning cent as 100 in French. Ah, see, it's tying together. 18% is what this is. Well, 1/4 isn't that much difficult, right? What do you have to multiply 4 by to get to 100? Well, 25. So 4 times 100 is 4 times 25 rather is 100. If you have to multiply the denominator by 25 to get it to 100, you have to multiply the numerator by the same amount. 1 times 25 is 25 over 100. Yeah, okay, 25.25 is the decimal point, okay, which means it's what? Yeah, 25%. Okay, easy. So if you've got a number that's really easy to change to, at least as a denominator, to change to 100, then all you have to do is multiply both the denominator and the numerator by the same number. Now, I guess you could do that with 5/8 and then multiply both sides by 12.5, but we start getting into kind of a complicated question there, right? And the numbers may not come out as whole numbers, and then it gets really complicated. So how do you do it when you can't easily change it to 100? Well, you do a little bit of work. First of all, let me show you how the answers turned out. 18 over 100 equals 0.18 equals 18%. 25 over 100 equals 0.25 or 25%. Okay, so what happens when you have a denominator that is not easy to change to 100? Well, if you have that situation, when you can't write an equivalent fraction, this is where you can use a calculator, and that's why we've added them all to the class, right? Because all you have to do is take the number for what it actually means. 5 over 8 is the same thing as 5 divided by 8. Okay? Okay, let's think about what that means. You know, if you divide 5 things by 8, you're going to get less than a whole number. You're going to get less than 1, which is exactly what you're talking about when you're looking at decimals and percentages anyway, right? So it's a portion of the whole. Therefore, that's the way to do it. If you did it the other way and did 8 divided by 5, you might end up with 1 point something, but it's going to be more than what you're shooting for. So you know you're going to be doing it the other way around. Same thing goes with 7/16. If I divide 16 by 7, it's going to be 2 and a little bit, right? But if I divide 7 by 16, it's going to come up to that decimal point I'm looking for. That's the way to think it through, okay? So always divide the numerator by the denominator to find what the percentage is and to find out also what the decimal point is. So if I do that, this is how it turns out. 5 divided by 8, if you did this on a calculator, would come up as 0.625, which is the equivalent of 62.5%. Now, if you were doing it and you were rounding things up a little bit, you could say that's 63%, okay? If you're going to be more accurate in mathematics, you're going to be doing this. If you're out putting a discount on a new blouse or a great pair of new running shoes, this is the way they would round it out. 7 divided by 16, if you did that quickly on a calculator, would come out at 40.4375, which is the same thing as 43.75%, which rounded up would come to 44%. Okay. Now, I'm not suggesting that you round everything up. I'm just saying that in most cases, when we're working on percentages, you just want those two numbers, but not in all cases. Okay. All right. So since we've gone through all of this and you basically know how to do it, what I want you to do is practice with the examples that are directly above me. Go through them, we'll discuss them in class, and then we're going to get into the basics of probability and start talking EQAO all this week, okay? Thanks for being here. Enjoy the rest of your day, and we'll see you tomorrow morning.